Welcome back to Titan Machine Tool. Forecast calls for snow. We have an accumulation, a couple inches of white Delrin. Yes, the forecast calls for snow. It's snowing over here today. Actually, what we're doing is we got some POM, aka white Delrin, that we're turning up here. These are discs. They're like 5-inch diameters. They were like 5.5-inch diameter originally to start with. Turned them down, face and turn, side one, leaving enough material to hold on to. They were oversized. They were like a little over an inch thick. They finished at 3/4, so I had 1/4 of an inch to hold on to. So first operation, I bought some soft jaws, held them in the soft jaws, face and turned from 5.5-inch diameter down to 5-inch diameter. Flipped them around, faced off the extra. So I got these discs. They're all the same. 5-inch diameter, 3/4 of an inch thick. We got to put some internal features into them. So this is what we're doing here. 3.966 diameter flat bottom, and then inside, if you can see it, there's a ID groove in there. 190 thousandths wide, 4.188 diameter. Internal groove. That's what's going on there. All right, so I brought them all to this point. So I got these discs, and we're gonna do the inside features now. Tool 1, 2-flute end mill. Essentially, it just plunges into the part, flat bottom, hole. Well, not really flat bottom, but more flat bottom than a drill, you know. Flat bottom, shy of the finished number, just so that the boring bar will have some place to go in. Now, ordinarily, I approach on the Z when I do rough passing, rough bore, finish bore, turning cycles, whatever, can cycles. Usually we go bore, come out, move over in the X, bore, come out, move over in the X, bore. But because what I'll do is I'll try to figure out which is the least amount of passes, whether I approach in the Z or whether I approach in the X. And in this circumstance, I can rough that all out with less passes approaching on the X. So the tool goes in and faces out to 3.966 less 10 thousandths for a finished pass. Comes back out, goes in 30 thousandths deeper, does that again. So it's gonna go 3/8 of an inch deep. So it took less passes to rough it all out approaching on the X than it would approaching on the Z. I would have needed more passes. So that's what's happening there. And also on the roughing pass, because this thing's an inch diameter and I go in and I got an inch diameter already missing from the middle, I don't face to 0 on the roughing passes because that would add a whole bunch of extra cuts going to 0. So it does a little funky path, but anyways, that'll rough it out for the boring bar to get in. Here's our boring bar right here, CCMT insert. It's got a 7 thousandths, 8 thousandths tool nose radius on it, so it doesn't leave any inside, very minimal inside radius corner. And then we got our grooving tool right there. Oh yeah, look at that. Isn't that thing awesome looking? Look at that. Kaiser thin bit to the rescue once again. That's it. I go and contact the salespeople over there. I contact Doug DeWitt over at any of the sales guys will help you over there. But I contact my buddy Doug over at Thin Bit right there, Kaiser tool, and that's what he hooked me up with to do my internal grooving. That's the tool. Here's the inserts. Oh yeah, that's right. Made in USA. Damn right. So this is a standard off-the-shelf insert, no modification right there. It's 125 wide. We need to go 190 wide, so we got a couple extra moves in there in order to get it to the proper width. Well, oh yeah, look at that. Ooh, I love new tools. Gets me excited. So this is what we're gonna do. We'll run it. Let's go. Enough talking. Let's make some snow. Start. Go. This guy goes in like a drill cycle. Essentially just goes in, couple plunges, roughs it all out. Gives a spot for the boring bar to go in. Finishes 380 deep. We're going like 365, leaving about 15 on the bottom with that one. Tool change. Let it snow, let it snow, let it snow. See, so now that's the approach. That's the roughing approach on the X. Instead of plunging in the Z, goes in 30,000, 30,000, spaces out. Goes in 30,000, spaces out. I probably could have gone a little deeper than 30 on a whack, but this way I can walk away from it and not worry. Look at the chips. It's snowing. And take a step back. Yeah, you can't really see them on the camera, but take my word for it, they're flying. Send me 100 more of these. So the next pass, it sounds a little crunchy when it approaches on the Z because it's getting into that flat bottom, that not so flat bottom roughed hole. I guess actually you don't get crunchy when you're cutting plastic. So now it's gonna come out and do its semi-finished pass right there. When it comes off the part, goes to Z0, faces the piece. It's only taking like a thou or two. And then it goes to the finished board diameter, 3.966, 10 thousandths radius on the very front edge to deburr it. It's facing to, it's not facing the Z0, it's facing to like 1 inch, which was the diameter of the end mill. And then it comes out so I can clear the chips. Now it's gonna go back in and take 3 passes. Let me show you. We didn't finish to 0. As you can see, the little mound here in the middle left behind from the end mill. We're gonna go back in and we're gonna take 3 facing passes across the bottom to make it flat bottom. Finish at 0.380, 381, something like that. So let's turn the spindle back on. Go. So essentially it goes back in at the finished diameter, 3.966. It goes to 376 Z depth, finishes at 380, 381. So right now it's pretty much cutting nothing because that's where the last roughing pass went to. But when it gets to the middle, it's gonna take some material left behind from the 1-inch end mill. So that comes out, does the same thing. I gave it a repeat. It repeats the same path 2 times with an incremental Z-depth plunge of 0.003 each time. So the first one's at 375, 378, 381 deep. My tool's not perfectly on center because it leaves a little tiny nub right in the middle, but I can break it off with my fingernail. So that's finished pass right there, 381 depth. I probably could go faster. I'm going like 425. Could probably run it faster. But it's cutting pretty good, finishes are decent, and I'm not running any coolant on it. Let's take a look-see. Alright, so see the little nubby left behind? My tool might be a little low, a little bit low on center, but it comes right off, there's nothing there. Snap it right off with my fingernail. So now we're gonna switch tools and we're gonna go to the grooving tool. Let's groove tonight. I'll stick to making chips. Forget about the singing. Man, I got snow all over my phone here. All right, so there's the tool right there. Kaiser thin bit. It's gonna go in, plunge, back off in the X. Then it's gonna go a little deeper in the Z to make up for the width, because the insert's only 125 wide, and we need it to be we need the groove to be 190 wide. So takes another little 2 extra cuts. Plunges in the middle, comes out, goes a little deeper, plunges again, comes out, and goes backs up to where it needs to be. Boop, plunges in again. So 3 passes to get the width. We're a little out of focus here. Make some chips. Talking too much. People don't like it when I talk. I got commentary in my comments saying, shut the hell up, you talk too much. It goes in a little deeper, takes another cut, backs out, takes another cut, and gets out of the way. And that's it. I actually go back in and rerun it just in case if there's a little spring. Can you see that? Probably not. But we got that undercut there. The front edge, 60 thousandths thick. This front lip right there, 190 wide, which puts us at 250 deep on that inside edge right there. All right, that's it. Titan machine tool. Cutting plastic today. It's not all that interesting, but I figured internal grooving, I can show you the tool and hook you up with a contact to get top shelf United States, USA made tools. They make all sorts of custom stuff over there too, so. You need a hookup, tray pans, ID grooves, OD grooves, micro tooling. They make all sorts of good stuff over at Kaiser Thin Bit, so you contact them if you need some tools. And I bought my tools, I didn't get them for free, so this isn't like, you know, a promotion. It is a promotion, but I paid for it, so. That's it, Titan Machine Tool signing off. Thank you for watching.